The ages of the members of a gym have a mean of 48 years and a standard deviation of 11 years. What can you conclude from Chebyshev theorem about the percentage of gym members aged between 19.4 years and 76.6 years? So what is this Chebyshev theorem? Let's review that. The Chebyshev theorem says at least 1 minus 1 over k squared, this proportion of the data, is within k standard deviation of the mean. And therefore, in order to get the k value, or in order to get how many multiples of the standard deviation these 19.4 and 76.6 is away from 48, you want to do the z-score, which is take that value minus mu over sigma. Okay, so x minus mu over sigma, you're using this. And if you compute them, you see that both are 2.6 standard deviation from the mean. In other words, if you say between 19.4 and 76.6, this is same thing as saying between mu minus 2.6, that's the value of k, so mu minus 2.6 sigma and mu plus 2.6 sigma. Now that we have the value of k at hand, we can plug that into this formula and get with k equals to 2.6, we can compute to get 0.852. So we know that at least 80, this at least is an important word, okay? So at least 85% of the population in the gym would fall in this age, which kind of makes sense. It's hard to see people younger than 19 years old, or like, I mean, there certainly are, but you wouldn't expect them to be taking a lot of chunk of the population, right? So if you say that about at least 85% of the people in the gym is between here to there, that sounds reasonable. Okay, so the important thing about the Chebyshev theorem is that notice that nowhere here it says anything about normality. So even without being normal, even if this data is skewed to the right or left, and or it's like it has like M-shaped data sometimes, even if you get those things, the Chebyshev theorem says that at least 1 minus 1 over k squared of the data is within k standard deviation of the mean. And then the correct answer would be that at least 85.2% of the data lies between 19.4 and 76.6. Now I want to add one more comment about the Chebyshev's theorem, because depending on what your textbook says, it might look a little bit different. So instead of having 1 minus 1 over k squared, you might subtract this from 1 and get 1 over k squared, and you have an equivalent alternative formulation which says at most 1 over k squared of the data lies outside of the k standard deviation of the mean, where k standard deviation means that k times the standard deviation. Okay, so that's what I mean by k standard deviation.